But for the time being, I'll just move on to the next adjustment until I can figure out what's going on here. I mean, it's out by about a volt. If I increase the frequency, then I can get that higher voltage there, but it's out by about a volt, so it might be an issue going on there. It might be a zeroing somewhere, or maybe a reference or something like that. I'm not sure. I'll have to look into it. So the last thing is the 100 kilohertz adjustment. So I need to go to 80 kilohertz and 100 kilohertz range. So 100 kilohertz range. And you want 80 kilohertz. And I should be able to measure between 79.6 and 80.4. That's pretty close. I'm going to give it a tweak. So that is this one here. And see if I can get that frequency right. So frequency stability on this thing isn't wonderful. They're not, you know, super duper in that way. It's not digitally controlled, it's just done by capacitors, so it's not perfect. Anyway, so that's well within spec anyway, according to this adjustment, you know, 1 hertz. So close enough. It's you know, considering it could be 400 hertz out, then you know, it's well within. So the next thing is set up 10 volts range. I test the oscillator 10 volts, so I messed with 1 kilohertz and to the phase lock input. On the okay, I need a 10 volts RMS signal at 1 kilohertz. Right. This is a bit drawn out. So basically it says to connect a frequency generating source. You can do 10 volts at 1 kilohertz into the phase lock input, and then 2 cables of the same length, approximately 2 feet, between the output of this and the E1 and the E2 inputs of the phase meter. I don't have a phase meter, but what I'll do is I'd use an oscilloscope. Compare on the oscilloscope. Set the mode switch operates sense. 0 to phase meter, disconnect the 5200A output, go to the phase meter, move it to the phase lock input. This is interesting. So it's really just looking for a phase adjustment using R52. And R52 isn't shown on that layout. That's helpful, isn't it? Hold on a second. So yeah, so all I'll do is hook up a signal generator source. Just trying to read this properly, hold on. Weird. I'm trying to understand what it's doing here. The way it's actually trying to set the calibration. But yeah, all you do, I mean, this is looking for a phase meter, but you connect it up to an oscilloscope. 2 channels on an oscilloscope straight in. You can check the phase on them that way. It has to be within 0.3 degrees apparently. Well, 0 degrees plus or minus 0.3. I can do that. I do have a signal generator sitting here. but I can't do 10 volts. My Siglent scope, my MSO scope here, that does have an AWG option in it. I believe it does 10 volts. So I might be able to use the output of that to feed this, then feed back in, but I'm not sure if that's going to create an issue with grounding, because it won't then be isolated. Because the grounding from the AWG will be ground on here, which may affect the grounding on the output terminal. If that's fed back in again, that'll affect the grounding in the output terminal. That may not be good. So it's probably not a good idea to do it that way. I need an isolated generator. And I just happen to have one on loan right now. That could be handy. Might have to use that one. That will give me isolation. Yeah, I need to adjust phase lock controls. Alright, so I'm going to just figure this out, then I'll maybe record some more video if I need to go into it a bit more deeply. Okay, so what I've got here is I've got this Siglent SDG 1032X signal generator here. It's on loan, so I was using it for something recently. It's supposed to have gone back yesterday. You know, I've got this teed off. I've got one input going into the input on the back here for the phase lock input. The other input is going to channel 2 on the scope. Now, this can only do 7.07 volts RMS maximum, so that's what it's set to. So it's a bit lower than the 10 volts it's supposed to be doing, but you know, it is what it is. That's okay. It's good enough to get a phase measurement. And I've got the output of this running into channel 1 of the scope. Then you can see there I've got the waveform set up. I've got the phase lock turned on, and it should then look for a phase lock plus or minus 0.2 degrees. Phase lock B, Oscillator Control Pcb is what I need to look at. So Oscillator Control Pcb, and I'm looking for R109, which is this one here. Phase lock B, there we go, that's right, it's marked on the casing. Should have looked at that a bit more closely first. So it is there. Now, the phase angle I'm seeing on the scope here is currently minus 3.74 degrees. Minimum, and maximum is 178 apparently. Yeah, so the current one is bouncing around a little bit. I think it's to do with the noise on the scope, eh? That's what I think is going on there, because it's jumping around. So you can see there's little lines, periodic lines in here. I don't know, maybe just because it's graticules, it lines up with graticules, might be nothing. Anyway, so I've shown enough waveforms on there, and it's about, well, it's jumping around a bit. So sometimes it shows 0 degrees, but sometimes it's mostly around high -2s, close to -3. So I'm going to look at that. So just R109, this one here, to try and get a better phase angle. Problem is, because it's jumping around, it's a bit hard to tell if I've got it right or not. If I have it fully clockwise, I'm seeing a lot of -3s popping up. Sometimes there's 0 again, like I said, but if I bring it all the way anti-clockwise, I'm seeing -1s, -2, -3, 0 again, -2, I'm not actually seeing it rock solid and stable. So it's just interesting that I can't adjust that properly. So I should be able to see a, a phase adjustment here, but I'm not getting it. If I missed something here, I mean, there's a phase lock A. I'm just not seeing anything really changing much. If I zoom right in here, I can see it moving slightly. I can see that purple line just moving by a fraction. It is actually adjusting, but not by much at all. Now, how much of that phase is due to the way the scope is reading the signal? I don't know. It could be something to do with that. It could be because the voltage level is different. So maybe if I drop this voltage level down to match what the generator is doing. Does that help? It does. It does. So let's make this generator 7 volts exactly then. Now they're overlaid on each other. So yeah, they're overlaid on each other. That phase angle now is actually making much more sense. It's now sitting. Yeah, that's good. Okay. Yeah, that's better. So that's what I was doing wrong. Okay, now because this can only do 7 volts, I have to set this to 7 volts. Well, obviously the 10 volts is to give it as much range as possible, much accuracy. But I'm using an oscilloscope. You can't get much more accurate than that. Alright, so it's fine. So now I can adjust this angle now. But what I'm seeing on the screen, although I'm seeing a phase change on the screen, I'm not really seeing it on the maths function. I'm seeing a slight change there, but it's not going all the way. In fact, it's gradually drifting downwards. Oh, because I'm looking at the wrong one. I'm looking at the mean. Should be looking at the current. Idiot. Idiot. Okay, so yeah, here we go. So fully clockwise and current's jumping around a little bit, about -2. As I bring it down, that's showing. That's basically 0 there, actually. Yeah, I'm getting like 0.03 there, plus. And it's supposed to be within 0.3 degrees. So I mean that's fine there, I reckon. See if I can give it more cycles, see if it affects anything. Maybe, yeah, it's a bit more noisy there. Yeah, okay. No, it's looking pretty good. The more cycles I've got on the screen, the more variation I'm getting in the actual readings. So there is obviously some noise going on here, which is causing jitter. It's not liking that jitter. But I think what I've got there is looking pretty good. That's not bad. And if I get this phase, you can just see there's a slight phase difference there, maybe. You might be able to see it. If I bring it all the way around, you might be able to see it. Yeah, I doubt you'll be able to see it on camera. But there's a purple line and a yellow line. And as I turn it, it's bringing it closer together. And eventually the yellow one will go behind the purple. Right, so it can, that visually they're in phase, but according to the display it's slightly off. Not much. So I might try and go for an average between the visual and the mass function. Yeah, that's looking pretty good right there. Okay, so I'm happy with that one. It's the thing, when you've got older test gear like this and you've got equipment which isn't available anymore, and you've got these old test techniques, sometimes you have to learn to adapt and find another way of doing the same thing. But first you have to understand what you're supposed to be checking for. Obviously what I'm checking for here is the phase lock, to make sure they're in line together between an output phase and an input phase, because they should match up. Okay, so that's what I'm checking for there. Next thing we'll do is phase lock A. So we'll do output of 10 volts and a 10 volt range. That's what I had already. Right. So I have 1 volt. Oh, there should be 1 volt there. Hold on a second. I might be doing this backwards. Okay, so it also says, after doing that 10 volt one, it says to do 1 volts and check for it still being plus or minus 0.2 degrees. Now, what I'm seeing here, as you can see, it's glitching, and I'm seeing some noise on that waveform now, but only at the 1 volt range. So there is something happening there, but obviously on the 10 volt range it's so small it's not seeing it. So let's just drop this voltage down some more to actually do 1 volt range. I'm seeing some glitching on here, but it's smaller, so it seems to be relative to the range you're looking at. If I do it on that one, there's lots of noise on that one. I can see lots of ripple on there, so that's very interesting. There's like little spikes on it, so there is something going on with this output being a bit noisy. Right, so it's just a little side note there. So let's bring this back down and go back to the next test, which is supposed to be, well, I'm going to do 7 volts again so it matches. On there and there. Right, 5 volts. Where's my... Oh, it's overlapping. There we go, so I can't see it. We're back in phase again. I'm going to do the same thing at... What we're going to do? Where's it gone? I missed a bit. Where's it gone? Lost it. Test oscillator output to 1 volt. Okay. So there's 1 volt on here. And I'll just bring this level up so I can see it. And 10 volts on here. Okay, let's do 10 volts on there. And adjust phase lock A, which is R52 for plus or minus 0.3 degrees, or 0 plus or minus 0.3 degrees. So that's definitely out by quite a bit there. So let's just try and adjust it. You actually see it moving around, hopefully. Cool, so it's jumping around a little bit. But it's looking damn close. Again, I think there's some noise in there, so that's fine. I think that's fine. Okay. So I'm supposed to go backwards and forwards. Let's go back to 7 volts on here. And 7 volts on here. and they should be still within phase. Yeah, supposed to go backwards and forwards between them to get them as close as possible. That looks fine. So that's enough of that. That's that bit done. Right, so next is supposed to be doing oscillator distortion. Now, what I was planning on doing, this is my oscilloscope there to do FFT measurement, but the smallest span I can seem to get right now is 10 megahertz of division, which seems odd to me. I can't seem to get that down. I'm not quite sure what I'm doing wrong. Probably some acquisition thing I got wrong. So I thought I'll just chuck it on the STM3065X instead, because this has got histogram option, and I've got to set the frequency, and this gives me a similar kind of FFT readout, I suppose. Okay. Now I'm supposed to be reading 100 kilohertz and checking for the harmonics and seeing how noisy the harmonics are, and adjust this to get those as low as possible. So I've got automatic histogram right now, and you can see where the spread is. It's not too bad, it's around there, no real outliers. Now if I adjust this pot, hope you can see, I think you can. If I turn this right up, you see it starts to shift. You start getting more up here. So I'll do a clear. I've got cumulative set on, so it's going to show what it's doing there. Right, so if I have it turned all the way up, it's showing a shift there. Bring it back down to the centre. You can see that's that noisy section. If I bring it right down to the bottom, then I'm getting response down here in frequency. So what I'm trying to capture is the noise section, right? So I'm trying to really see the harmonic of 200 kilohertz. But if I go into binning here and get the manual, bin settings, high, if I go and set that, say, increase that a little bit, 204, right? Done. We'll see if this shows anything. It may or may not. If I turn it all the way one way, nothing really showing up. All the other way, nothing showing up. So if I go to more bins, let's give it 200 bins. Turn it the other way again. Nothing. So this isn't really telling me what I need to know, at least not in this case. But I can see the frequency changing when I do the other graph. But in this case it's not doing what I want. I mean, I really get the scope to do it. The FFT on the scope is what I really need to get working. So I might just go and play around with it. I'm sure I can do it. I just obviously got something set up wrong there. Okay, so I've got the FFT working on a Siglent scope there. I was just using it wrong, so I don't use the FFT very often. And every time I do go to use it, I forget to do it. So anyway, I've got an FFT readout now. And I've got it centered at 100 kilohertz with a 20 kilohertz span, or 20 kilohertz per division. But the update rate's a little bit slow for what I'm doing here, I think. We're going to use a special analyzer, but that's put away. I can't really get that out. So this will have to do for now. But the idea is adjusting this oscillator distortion adjustment hit right here, right there, to get minimum noise on there. I'm not really seeing much change. I'm not really seeing much variation on there. So I'm just going to move on from that one. I'm going to put it back to where it was, which was in the centre, which I found worked best for doing the other stuff I was playing with earlier on. In the centre position, just leave it smack bang in the centre and I'll move on. Because I can't seem to get much sense from that particular adjustment. So the next thing here is to go 1 volt division, or sorry, 1 volt. Is that 1 volt 10 volt range? I'm doing oscillator 0 calibration now. Alright, so 1 volt 10 volt range, 1 kilohertz on the 10 kilohertz range. You get to see the FFT playing, you know, changing at the same time. Disconnect the white coax cable from J51 on the ACD signal. Connect the shields together. Sure, I click. Connect DVM between TP1 and TP7 on the oscillator PCB. Actually, I still got that face lock turned on, haven't I? What that's going to do with what's playing up? Anyway, on sensor oscillator 0 plus or minus 5 millivolts. Okay, so I've got to strap a coax together. Just put it there. It's going to be hot in here, so I might actually just shut some gear off. Let's turn it off. Disconnect that. So we want to unplug J51, which is this coax here. Put this off. Okay, it's actually trapped in there. It's not good. Anyway, I'll sort it out. So I need to strap there to there. I want. Let's do this without shorting anything out. That'd be quite bad. Don't move. So I need a crocodile clip thingy or something. This will do. Piggybacks from the cables together. So I clip that onto there like so. Clip that onto there like so, because it requires the connection between them in order to work. So that's not strapped together. DVM between TP1 and TP7 on the oscillator PCB. TP1 and TP7 on the oscillator PCB. Right, well, let's get a. Yeah. Now TP1 is the ground, so I'll stick this on there. That's nice and easy to get to. And TP7 is over there. I can get to that one easy too, so I'll stick the clip on that one as well. I'll check the camera angle, see if you can still see what I'm doing. Hopefully you can. Let's make sure. Right. So it's on. That's all as it should be. That's all cool. Yeah. That's what it should be. Switch on, sense to internal sense. Yep. Oscillator 0, R2 oscillator PCB 0 plus or minus 5 millivolts. R2 is right here, so I should be getting 0 plus or minus 5 millivolts. It won't adjust. Isn't that interesting? Should that be DC volts rather than AC volts? That might make more sense. Here we go. Right, DC volts. I was measuring the output before, that's what it is. Okay, so 0 in there. It's looking pretty much just going plus and minus a little bit, so that's looking pretty zeroed. Let's just look at the graph on that. I'll see what that's doing as far as voltages go. So that TP7 is actually a bit noisy. So let's make a note of that. So TP7. Also old. Noisy. So again, let's have a little clue to what could be going on there. Even you see it jumping over the place there, that's not what's supposed to be there. It's supposed to be rock solid. So maybe I'll just look at the chart while I'm doing this adjustment and see if that changed anything again. Probably jumping a lot. Could just be a dirty pot. So let's just work it a little bit and see if it changes anything anyway. There was around the centre position as well, was zeroed. So that's, yeah, so it was around the centre position where it's zeroed. Still clear. And let's get rid of a tweak. Okay, let's clear it again. And it's microvolts is changing by. Okay. So maybe it's not that bad. Plus or minus, or it's doing plus 100 microvolts, minus 200 microvolts. So it is a little bit of noise, but it's not that bad. I think it's better than it was now, giving that a bit of a twiddle around. So I think that's acceptable. So, what's next? Reconnect J51, yeah, well, okay. Then you've got power amplifier 0. I wish people stop coming out the door, it's bloody noisy. Fuck. Right, so power amplifier 0. So let's disconnect all this stuff next. Get this back out of it. Take that off. Put that back in again. Okay, so power amplifier 0, what do we have to do for that? We've got to be careful with this thing because it's got metal clips on it. We'll have to be careful and short things out. Ensure setup, yeah, okay. Hit AC quick, oh god. So it's referencing somewhere else for the setup. I just need to go and look at that. 4.3. Referencing setup 4.3. 4.3 is, let's put this guide back on top actually on this or this. So 4.3 is this thing here, which is sense lines not strapped together, going through a differential voltmeter between the output and sense. Okay, so replacing the differential voltmeter with a Fluke model blah 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 AC to DC differential voltmeter. Okay, so I've got to take the output strap off. Oh god, where's shut the door? Right, take the output strap off. I'm going to go and lock it in a minute. Okay, so I've got a setup like this, which is with the strap taken off it, coaxial cable going to this, in theory, in order to get a microvolt DC level. Okay. Right. Well, this is going to be a little trickier. Okay, I'm going to shut this off and I shall reconfigure this and try some stuff, then I'll carry on recording if it works. That fucking door. Okay, so I've moved on to the RF power amplifier 0 adjustment. Now it does describe how to do it with that figure 4.3, but anyway, I've hooked up some stuff here between the ground terminal and the output and sense. Now the output and sense is supposed to go to the meter and link together the meter. I've not done that. I'm just keeping the links in place at the front panel and just doing it there. It's probably not going to be perfect, but it's close enough. So what I've got my Siglent 3065X here set on temperature scale. Right, now what you can do when you're on temperature range, you can actually measure temperature value, or measured value. And this allows you to measure really small voltages, right? In this case, microvolt DC. And it's actually showing up easier on here than it is on this range here. See, this is jumping over the place. It's just a bit hard to make sense of. Okay. If I increase the resolution a bit, it'll be a bit smoother, but you know, it's still all over the place a bit there. Okay, turn all that zero off might help slightly, but you can see it's there. It's jumping around. Yes, I could do it there. It's not, you know, it's okay, right? But if I go to the temperature one, it'll give you a microvolt DC readout. Why not do it there? It's just easier. Okay, so what we'll do, you can see it's jumping everywhere, and we'll just see what we can get out of it. They're supposed to be 0 plus or minus 200 volts, so I just want to see what ranges we've got here. Go all the way one way, all the way the other way. So it's about 900 or minus 900 or so in one direction. Go the other direction. So it's about plus 900, so that's fairly well centered actually. So that's pretty good. So let's just try and go for 0. Just jumping around a little bit there. But it's plus and minus, so it's sitting quite well. Let's look at the DC volts one again and see what that one's saying. If I go to more places, or PLC is power line cycles, what PLC means. So this helps to smooth it out a little bit. And I mean, yeah, that's pretty much there, isn't it? Auto zeroing also slows it down. It's going plus and minus about the same amount, so you could say that it's pretty much there, isn't it? Okay, so we go back to display and look at the trend chart again. We're actually showing microvolts here in the swing here, so it's plus 35, minus 41 microvolt right now. Around with minus 2 microvolt being the centre. Minus 8 microvolt being the centre, so it's well within spec. It's supposed to be, you know, plus or minus 200. So that's that one done as best as I can anyway. I think it's not ideal, but it should do the job. So voltage, amplitude, and linearity calibration. This looks a bit more involved as well. So I'll have a read of this and I'll come back. Okay, so I've been gone ahead a little bit here, and because I was going through this calibration. It mentions using a reference standard, which is hooked up to a Fluke 5200A DC voltage calibrator. I do actually have one over there, one I repaired in the previous video, so I do actually have a 343A, but I don't have the transfer standard, which is a 540B. Now I'm wondering if I should buy one. Basically what it does use is a thermocouple type connection, so you can get a really good averaging of an AC signal and a DC signal in order to do nulling and comparisons between the two. So I don't have anything like that, so I'm just doing a AC measurement, a raw AC measurement, and hoping for the best basically. So I've calibrated 1 volt range. I've also done the 10 volt range. 1 volt range is, say, there's that noise on the output there, which is making it hard to get right. It's close. 10 volts has got a similar kind of deal. Just reset that. What I've done is we've gone in and adjusted the reference calibration in here. Although I might need to adjust it again, it's like it's still not quite there. Get back in there. So I should be setting this for 10 volts. In theory, if I can get the screwdriver back on it, it'll be good. It's in there somewhere. Let's try that end. In case that will work. No, it doesn't go through the hole. So, alright. I did it before with this one. There we go. That's in there. Right. the wrong way. You go the other way. Okay, that's pretty good there. Pretty good. So 10.000000 and that goes. So anyway, it's not stable, so it's only for now. It's already changing around a bit. That noise is not helping. Okay, so that is working like that. The next thing to do is the 100 volt low frequency calibration. So it should be the same kind of thing again using transfer standard, which I don't have, as I said. So 100 volts on 100 volt range, just like that. AC volts is the auto ranging. Back to display. Very clear readings. Okay. So I should be able to get just R9 on the attenuated PCB for transfer standard. Yeah, well, plus or minus 5 millivolts. Well, I'm already within that. I'm plus or minus 2 millivolts right now. Looking at that. But again, it's jumping up and down a little bit there. It's not wonderful, but it's pretty damn close. I'm probably going to leave it right there actually. These are slightly on the high side. Let's have a look. So just 100 volt R9, which is this one there. What type is that? One of them. Okay, shove that in there. Let's give that a bit of a tweak. And a bit more. There we go. I think that's come down slightly. A bit more. Yeah, that's pretty damn close there, look. That's sort of within 1 millivolt. But again, there's noise, so this may change when I find the source of that noise. That might be slightly too low actually. No, I think it's just the noise that's throwing it out. That's pretty damn close. Right, that's less than a millivolt. Okay. What's next? High frequency. 10 volts, 10 volt range. So 10 volt range, 10 volts, and 1 megahertz. Done. Clear readings. And adjust high frequency 0. That one. Yeah, that one there. High frequency 0. For the same errors recorded in step C, which was measuring the transfer standard error. So I guess I'll just go for 10 volts. Now, what kind of adjustment is that? It's that one. Okay. Oh, I was right around. So we're going to drop in there. There we go. Right, so I want to go for 10 volts on this. I believe. I went the wrong way. Seems to be a long way out. Not sure this is correct. that's fully in. So let's bring us back. I'm not sure that's right. So I'll bring it back up to around halfway, which is a 10.3 I think it was. Okay. We'll see what's saying. It's been on 10.3 there because that seems a bit strange. Okay. Interesting. There should have the same amount of error apparently between 1 volt and 10 volts. That's the 1.06. Interesting. That's quite a large error. Let's check some of the other ranges. Yeah, they're not linear. They're all slightly high. Even a 10 volt one. I'm going to bring this reference back down again. I'm sure that's right because I did adjust that by a lot. Sure, I'll do it that way around. Now I've adjusted this reference previously, so I was surprised that I needed to adjust it by so much. So let's just try and get this back in. Adjust it back. Hopefully. What's this thing doing right now? It's being a bit weird, actually. That's what it's doing right now. Something's not right here. I'll have to go back and look at that again. I think I've stuffed something up. Let's look at this one again. It's low frequency 0 again. So 1 volt, 10 volt range. 1 volt, 10 volt range. That's in 0. Yeah, something's not right here. 1 kilohertz. Is that what I'm doing wrong? Maybe. Let's have another look. No, it's looking pretty close there. No. They're suspicious this isn't going right. That noise isn't helping. So 10 volts again. And I did a reference again to get 10 volts. It just seems weird. I'm going to leave that there. I don't know, it just seems strange. I'm not sure this is right. So 10 volts, 10 volt range. Yeah. 1 megahertz, 1 megahertz range. Yeah. Clear readings. I'm getting a very different voltage reading. Don't know, I might just move past that step, see what else happens. Adjust high frequency gain. Maybe look at that one. Maybe it's the gain which I should be looking at. What kind of adjust is that one? Can't even tell. Like that one there. Okay, turn this one down. Don't do it or not. That's at the end of its adjustment range. So I might stick that in the middle. I think that's wrong though. Don't know. That seems weird. Without having the proper equipment, I could be doing this completely wrong. Alright, so 10 volt again, yeah. Set the DC calibrator, yeah. Oh god, just transfer different. So, okay, I'm going to set this slightly lower to simulate what it would do. Since I'm reading on this, it should be fairly accurate. That's the value it says to use. 10 volts, 100 volt range. I'm not in the right range, am I? I can't do that. I can only do this. Oh well. Let's see what happens there. So it's trying to set it for a voltage level of 9.967 based against a DC reference using the transfer standard. So we need to try and get 9.967 on here. .100 volt high frequency. That one there. What kind of adjustment is that? I can't even see it. Right, let's have a look. Oh, it's right down inside there. Let's just make sure we can get onto it. Oh, there we go. Right, onto it. So 967. We'll set it for that. Or something very close to it. Right. Put that going in. So yeah, I don't know. Just suspicious something's not right here. So I'm going to have to leave the calibration with that question there about this whole high frequency and adjustments, all this attenuated card stuff, because it seems I don't have the right gear to do that particular calibration part. So what I'm seeing on here doesn't really make sense compared to what I'm supposed to be getting from the manual. I don't think it's a fault, I think it's just the way it reads, and the fact I'm not using the bit of test gear they want me to use for the calibration. So yeah, I don't know, but we'll see how it goes. I mean, I was looking at this graphing now. So this is on the 10 volt range. I'm getting 200 microvolts up and down on 10 volts. 1 volt range. I'll sort of just have a look and see what the noise is like on these, you know. 1 volt range is about 50 microvolts up and down. 100 millivolt range. So I'm slightly low on that one, interestingly. 99.99, but again there's lots of noise in here. This is about 1 millivolt noise. So 10 millivolt range. So what we get in here. Yeah, this is setting slightly high. About 80 microvolts high. I'm getting a swing of, yeah, about 12 microvolts each way. 1 millivolt range. So it's 1 millivolt, and I'm getting 1.07 millivolts. I'm getting about 200 microvolt swing, I think. So yeah, I mean, it's not too bad, but it's noisy.